Hi guys, this is Mrs. Boone, and today is May 14th, and today's lesson is going to be lesson 4 in chapter 11 on translations and reflections. So in the next few sections, we are going to talk about different types of transformations. And transformation is changing an image in some prescribed manner. Whether it's moving it, flipping it, sliding it, or enlarging it or reducing it. Okay, so today's lesson is going to be on translations and reflections. So let's get started. A translation is simply called a slide of the shape. Okay, translation. Original and translated images are congruent or stay the same shape and the same size. And orientation is also the same. So if it's facing to the right, it's still facing to the right. Okay, you're simply sliding the shape. Let's take a look at this example in front of us. The rectangle ABCD was translated. Now, in order to find out how it was translated, you can actually tell this by looking at one of the vertices. So I'm going to take vertex B, and I'm going to see where is my vertex B in the other shape. Now, you're probably noticing that the translated rectangle has a letter and then a little apostrophe next to it. We call it a prime in math. So the way we read it is A prime. Okay, that means that shape was translated. So let's take a look. If I take a look at a vertex B, remember we translate the shapes first left or right and then up or down. You cannot translate the shape diagonally, even though it does look like it was translated diagonally. So let's take a quick look to see how many units did we translate this to the right. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units to the right and 1, 2, 3, 4 units up. So 9 units to the right and then 4 units up. 4 units up. Okay? And we do write these translations as an ordered pair. So remember, ordered pair has X and Y. Oops, X and Y. So 9 units to the right means positive 9. And 4 units up means positive 4. Remember, up and to the right is positive translation. And left and down is negative. Okay, so that's how you can tell how many units it was translated. So let's take a look at our example. In the example 1, you have a triangle ABC with 3 vertices, and it is translated 2 units to the right and 7 units down. So the translation is represented by this ordered pair. Okay, this ordered pair right here. Positive 2, negative 7. 2 units to the right and 7 units down. So now I'm asking you to find the coordinates of the translated triangle. A prime, B prime, C prime. Okay, so I showed you how we do this on the graph paper, but you can actually do this mathematically. And the only thing we're going to do is we're going to add the translated ordered pair to the original ordered pairs of each vertice. So let me quickly add that. So let's see, plus 2, negative 7, plus, again, we're going to do the same thing to every single vertex. Okay. So let's quickly figure out what we do. How in the world are we adding two ordered pairs together? How in the world are we going to do that? Well, simply we're going to add x's and y's together. Remember our integer rules, adding same sign, add and keep, different sign, subtract. Remember this song? And let's refresh our memory on that. So -2 plus 2, okay, will be 0. So a prime will be 0. And then 7 plus -7 would be 0. Okay, so our first vertex will have an ordered pair 0, 0. B prime is -1 plus 2 is 1. And 0 plus -7 is -7. And then, of course, C prime. 5 plus 2 is 7. And then 5 plus -7 is -2. Okay? And if we had, if you're not sure if you did it correctly, you can always plot the original ordered pairs and then plot the translated ordered pairs and see if they translated 2 units up and 7 units down. Our next example, I'm hoping that you're going to pause me and try this on your own. So please do that. And I'm going to quickly solve that. So again, translated 4 units to the left and then 5 units up. So to the left means -4. Left is negative. And then 5 units up is positive. So we are still going to do the same thing. We're going to add our ordered pair. -4, 5 plus -4, 5 plus -4, 5. Okay. Let's quickly figure out our primes. So A prime will be -3 plus -4 is -7, and then this would be 11. B prime will be -6, 2, and C prime will be -9, +6. Okay, so I'm hoping that this is fairly clear. And let's move on to our next part of this lesson. And now we're going to talk about reflections. Now, ladies and gentlemen, reflection is called a flip. Okay, think of it as a mirror image. When you looking at yourself, you see your reflection, right? And you don't see yourself facing away, right? You see your face. So your face was flipped over the mirror line, and that's why you see your reflection. So in the reflection, which we call a flip of the shape, figures are mirror images of each other. Both images are congruent. So again, the size and the shape does not change, but the only difference is the orientation is different. Okay? So in this example right here, you can tell that the shape was reflected. Now, we reflect the shape over either y-axis or x-axis. So think of it as kind of jumping over axis or the mirror line. So reflecting over y-axis, you're kind of jumping over, right? And then reflecting over x-axis, you will be jumping this way. Okay, you will be jumping this way to top or bottom, reflecting over x and then reflecting over y, where you're gonna jump right or left. How do we find out new coordinates after the reflection? Well, if you have a grid and you have a shape, it's very easy. Remember that both images are congruent, but also every single vertex of the shape is the same distance from the line of symmetry, or mirror line we call it, right? So if you take a look at this vertex right here, you will see it's only 1 unit away from the line of symmetry or mirror line. And then if you jump again 1 unit to the right, I'm reflecting this vertex. So that's how we do it. We just count how far that shape is away from the line of symmetry and jump the same amount from the line of symmetry to the other side, the same number of units, and then goes for again, if we're reflecting right or left, we're jumping to the right or left. If we're reflecting over x-axis, we're jumping up and down, and that's how we jump with every vertex. So let's take a look at some rules that, let's say you don't have a grid and you would like to reflect, and your teacher is asking you, hey, what are the new ordered pairs for every vertex of the shape? And then we can take a look. There are some rules. So when you reflect a shape over x-axis, x stays the same. So over x-axis, x stays the same, and y coordinate changes to the opposite number. So if it was positive, it becomes negative. If it's negative, it becomes positive. When you're reflecting the shape over y-axis, then y stays the same and x changes to the opposite. Super easy. So ask yourself, reflecting x over x or over y, and then that coordinate stays the same and the other one changes to the opposite. Let's take a look at our example. I'm only going to give you one example. You're going to get plenty examples on Khan Academy. So let's take a look. We have a triangle ABC with different coordinates. I'm asking you to reflect it over y-axis and x-axis. So let's take a look and reflect it over y-axis first. So the first thing we need to do, we actually need to graph, right, the original shape. So let's do that. I'm going to make my original shape regular black color so we can distinguish between different colors and different reflections. So triangle ABC, A is negative 3, 3. Okay. B is negative 2, negative 1. That's B. This is A. This is B. And C is negative 5, negative 2. Negative 5, negative 2. Okay, that's C. And I'm going to connect these. 1, 2, 3. Oops, that did not do a good job. Okay, I'm going to leave it just like that. Okay, so the next, let's see, I said we're going to reflect it over a y-axis. So y-axis, again, think about jumping over y-axis. So you can do this using your grid, okay? And then you can count 1, 2, 3, 1, 2, 3, and that would be your A. Same thing for B, 1, 2, 1, 2. And C, we will have 1, 2, 3, 4, 5 units, and then 1, 2, 3, 4, 5 units right here. So your, no, I don't want you. Okay. And remember, we are reflecting it. So this is a C prime, and this is B prime. Okay, so these are my prime, A prime, B prime, C prime. I reflected it over y-axis. Now, again, I'm going to follow the rules now and show you. So A prime, remember when you're reflecting over y-axis, your y stays the same, x changes to the opposite. So A was negative 3, 3. Y stays the same, so it's going to be 3, 3. Okay. B prime is going to be negative 2, negative 1. So negative 1 stays, negative 2 changes, so 2, negative 1. And then, of course, C prime is going to be 5, negative 2. Now, that's using the rules, and if you can, after you use the rules and take a look at your vertices, you will see that it's 3, 3, 2, negative 1, and then 5, negative 2. See how easy that is? Super easy rules. Now, let's reflect it, and I'm going to use, let's use green color. I'm going to raise this up a little bit. Okay, so let's reflect it over x-axis, and I'm jumping up or down, right? Okay, so again, you can do so by just looking at the vertex and then moving it 3 units down and 3 units down, right? A, B, and C. What I'm going to do is I'm going to use the rules. So now A prime prime, because we already reflected it once, I'm going to do 2 primes. And then over x-axis, x stays the same, right? Y changes to the opposite. So -3, -3, B prime prime, x stays the same, B changes to the opposite. I'm sorry, Y changes to the opposite. And then C prime prime, x stays the same, so that was -5, and +2. Okay, now that I've done that, I'm going to go back and plot these points. Let's see, -3, -3. Okay, that's A prime prime. B is -2, 1. -2, 1 is right here. That's B prime prime. And C prime prime is -5, +2. Okay, that's my C prime prime. Okay, and I'm just gonna connect them. 1, and I'm gonna do 2 and 3. And I don't want that. Okay, my shape is better. So notice it kind of looks kind of flipped, right? When you reflect over x-axis. So that is pretty much it. Again, it's up to you. Follow the rules, or just count the number of units up and down, left or right, depending on how you are, which axis you are reflecting the shape over, and you will be just fine. So please email me if you have any questions, and I will see you tomorrow for our next lesson. Thank you.